Hello, welcome to my channel this morning. We are solving some S1 questions on permutation and combination. I have compiled past questions from 2019 to 2020. Okay. Actually, I added the 2020 because it's the current year, and I added February 2020, May, June 2020, and then October, November 2020. So I'm going to analyze the questions. I'm going to solve it the way that is easier for you to comprehend so that you can apply these techniques in your own solutions. Okay. Try to other questions and see whether you get the answers correctly. Okay. So we will start with let me check this here. That's 5/2 October, November 2020. So that's where we are going to start with. So let's get right into it. It says that Mr. and Mrs. Ahmed with their 2 children, and then Mr. and Mrs. Baker with their 3 children are visiting an activity center together. They will divide into groups for some of the activities. In how many ways can the 9 people be divided into a group of 6 and a group of 3? Great. So now this is how you are supposed to understand this story. 9 people. Which group did they mention first? The group of 6. So if you have 9 people, okay, so that's 9 people, you are going to choose 6, okay, to fill the first group. So that's 9 combination 6. Then how many people are left? 3. So those 3 people now will be chosen to fill the second group. So that's 3 combination 3. So let's put it on our calculator to see what we get. So that is 84. 84, okay? For your 2 marks, and you are good to go. Now, the B part of the question says 5 of the 9 people are selected at random for a particular activity. Find the probability that this group of 5 people contain all 3 of the Baker children. All 3 of the Baker children. So once it's about probability, probability, we define probability as let's say probability of an event E is the number of events E over the sample space, right? That's what we say. So now the sample space is the 5 people that you are the 9 people that you are going to choose 5 from. So that the sample space is basically 9 combination 5. Okay, but now it's left with the event itself, and the event is that you are going to choose 5 people, but 3 are already selected because it says that it must contain all 3 of the Baker children. So you are not going to select 5 people anymore. Okay, you are now going to choose 2 to go and add to the 3 Baker children so that you will have your probability. Okay, so let's say the number of events itself would be, since you have selected 3 people already, it reduces the sample from 9 to 6. Okay, so that now there are 6 people that you are going to choose 2 more to go and join the 3 Baker children. Okay, so that's 3 combination 2. Therefore, your probability, all right, will be equal to 6 combination 2 over 9 combination 5. So let's put that on the calculator and see. 6 combination 2 over 9 combination 5, and that gives us 5 over 42. Okay, you are done for 3 marks. That's good. Then let's look at the C part. The C part says that all 9 people stand in a line. Find the number of different arrangements in which Mr. Ahmed is not standing to Mr. Baker. Ahmed and Mr. Baker, maybe one is cheating, with the other person's wife. So when they stand together, they are going to fight. Weird stuff happen. Anyways, so Mr. Ahmed and Mr. Baker cannot stand each other, okay? They hate each other. So what is the skill here? What is the trick here? Well, the question tells us that 2 people cannot be together. but doesn't say that the remaining 7 people cannot be together. Okay, so you start by arranging the 7 people. Okay, now this family is made up of Ahmed, the wife, the 2 children, Mr. Baker, the wife, the 3 children. Okay, so let's give them names. Okay, the children for Ahmed will be A1, A2, and then the Bakers will be B1, B2, B3. Okay, then Mr. Baker should be like MB, and then the wife will be WB, wife of, and then Mr. Ahmed, ME, the wife, WE, something like that. Okay, so let's arrange those that have not been told that they cannot be together. Okay, so let's have WA, that's the wife of Ahmed, A1 child, first Ahmed, A2 second Ahmed, then we have WB, Mr. Baker's wife, and then B1 for the first child, B2 second child, B3 third child, right? So you arrange and you leave spaces in between them like that. The next thing I want you to do is to put dashes starting in front of Mr. The wife of Mr. Ahmed to the last person. Okay, so we have dash, 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 and dash. Okay, dash throughout. So now, how many people have you put in your work right now? There are 1, 2, 3, 4, 5, 6, 7. Right. So that means there are 7 factorials to arrange these people. Times. Now, the dashes there, how many are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 dashes. And we are going to arrange 2 people. Okay, that is Mr. Ahmed and then Mr. Baker. Therefore, that's 8. Since you are going to arrange 2 people, it is permutation 2. Okay, so 7 factorial times 8 permutation 2. Let's put that on the calculator. All right, we have 8 permutation 2. So that gives us 282240. Great. All right, so this is how to think about it. This is how to analyze it. Okay, don't get scared. All right, then the next thing that they are talking about is what? Find the number of different arrangements in which there's exactly underlined exactly 1 person between Mr. Ahmed and then Mr. Baker. So you put Mr. Ahmed there, put Mr. Baker there, put a dash in between them so that there's exactly 1 person in between them. Okay, so MA for Mr. Ahmed, MB for Mr. Baker, right? How many people are there in all together? 9. So we've arranged what? We put 2 there, so we are left with 7. So 1, 2, 3, 4, 5, 6, 7. Okay, now another thing is that since we want a situation whereby there's exactly 1 person in between Mr. Ahmed and then Mr. Baker, then once we have put the dash in between them, we should what? Put maybe a box around them so that those 3 people are in some small bubble that they are always moving together. If we don't put them in a circle or in a box or something, what actually happens is that Mr. Baker can leave, Mr. Ahmed can leave, or more people can come in between them and it wouldn't satisfy the condition of the person. We want exactly 1 person in between them. Okay, so let's put some nice box around them like that. Now, once you put a box around them, it's treated as 1 unit. Okay, so now how many units do you have to arrange? You have 1, the whole thing is 2, 3, 4, 5, 6, 7. Okay, so that means you have 7 factorial ways to arrange. But you are not done. Go inside the box. You see, you have Mr. Ahmed over here and then Mr. Baker over here. They can flip, okay? So that Mr. Baker comes here, Mr. Ahmed comes here. So there are 2 ways to arrange this. So times 2 times. Now, if you put Mr. Ahmed here and Mr. Baker here, we are left with 7 people. Any of those 7 people can be in their middle. All right, so you are going to arrange, from the 7 people, you are going to arrange just 1 person in their middle. So that's 7 permutation 1. 7 permutation 1. Or you can just say that there are 7 people who can fill that slot. So just times 7, because 7 permutation 1 is what? Is 7. So let's see. Actually, we are done with the question, but let me just go off topic for a minute and come back. What if the question said there are exactly what 2 people in their middle? So you would have done everything right, but when it comes to the middle, you would say 7 permutation 2. Okay, 7 permutation 2. If there are 3 people in the middle, you do everything that you're supposed to do. Then when it comes to inside the box, 7 permutation 3. So that's the thinking. All right, so let's go back to the question and answer. So you have 7 factorial times 2 times 7 permutation 1, and that gives us 70560. All right, for your 3 marks. So that is paper 5-2 of October, November 2020. Let's move on to the next paper. I think this is what 5-1 October, November. Okay, talks about shopkeeper. It says find the number of different ways in which the 10 letters of the word shopkeeper can be arranged so that the E's are together. Excuse me, it says the E's are together, right? So let's put the E's together. That's what they want. So we have E, 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 they are together. Put a box around it. What it is left, we have S, we have H, we have O, we have P, we have K, we have P, we have R. Okay. So now, how many units do we have here? 1, 2, 3, 4, 5, 6, 7, 8. So that is 8 factorial ways to arrange. But don't be quick to end it, because you have P here, P there. The P's are what? Repeating. So you divide by 2 factorial. Well, someone will say, we have to go inside the box. Yeah, that's true. But I wouldn't really tell you to go inside the box, because inside the box, there are 3 what? Items. So that's 3 factorial ways to arrange. But these items are actually repeating. So that's divided by 3 factorial. Now, 3 factorial by 3 factorial is 1. So why go inside the box if the things are identical? I mean, but if you want to go, why not? I mean, it's all part of the workout. It shows that you really understand what you are doing. So that's 8 factorial over 2 factorial times 3 factorial over 3 factorial. And that will give you 20160. Okay. Then the B part says, find a number of different ways in which the word shopkeeper can be arranged so that the P's are not next to each other. P's are not next to each other. P's can be together, period. Okay. All right. So if P's cannot be together, what other things were not mentioned that can be together? So everything can be arranged except the P's. So let's start with that. So we have S, we have H, we have O, we skip the P, so we have K, we have E, we have E, we skip the P, so we have another E and then R. Okay, when you finish, I want you to put dashes in between them. Start with a dash, end with a dash. So you have dash, 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 and dash. Great. So from S all the way to R, how many are there? Let's check it out. 1, 2, 3, 4, 5, 6, 7, 8. So they have 8 items. 8 factorial ways to arrange, but the identical items, the E's are 3. They are repeating. So let's divide by 3 factorial. Now you want to deal with the P's. How many dashes are there? Slots that the P's can fill. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, you have 9 slots that you want to arrange 2 items. So you want to arrange means you want to do 9 permutation 2. You want to arrange. But be careful, the P's themselves are identical. So you have to divide by 2 factorial since there are 2 P's there. So let's put this on the calculator. 8 factorial over 3 factorial times 9 permutation 2 divided by 2 factorial. And that, ladies and gentlemen, will give us 2419290. Yeah, this is it for 4 marks. You see, it's really easy. I told you. Then, the C part says, find a probability that a randomly chosen events arrangement of 10 word shopkeeper, blah, blah, blah. But the most important thing is that they said that the beginning is starting with E and the ending is E. So let's do that. Start with an E, ends with an E. Okay, that 10 things, and now you've chosen 1 here, 1 there, so you're left with 8. Now, the fact that they are saying probability, be careful. Be careful. Don't just do the arrangement and end it there. It's probability. So you have 8 in the middle. There's 8 factorial, but some of them are repeating. The e's, okay, the e's are actually not repeating because you have 1 e here, 1 e there. But the p's are repeating. They are 2. So divide by 2 factorial. So there's a number of ways to arrange when e begins, e ends. But that is not the question. The question wants probability. So you must divide by no restriction. So no restriction, that's, the total sample will be the 10 letters that you have. So 10 factorial. P's are 2, divided by 2 factorial. And then the e's are 3 factorial, right? So your prob of blah, 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 when the e end and e begins, e ends, is actually 8 factorial over 2 factorial times 10 factorial over 2 factorial times 3 factorial. Right, so you just put it on a calculator. If we're working a probability and you don't divide, is that really a probability? Probability is something divided by something. Okay, so that's 8 factorial over 2 factorial times 10 factorial over 2 factorial times 3 factorial. And that, oh, it's not times. Did I say times? That's weird. It's division, so why will I put times there? Okay, sorry about that. 8 factorial over 2 factorial divided by 10 factorial over 2 factorial times 3 factorial, and that is 1 over 15. You know what happens when you're working a probability and then your answer is more than 1? Advise yourself, you are wrong. Okay. The D says that 4 letters are selected, okay, are selected from the word shopkeeper, so that it contains exactly 1p. Now be careful, you have 4 letters, it contains exactly 1p. P's cannot be 2 there, 1. Now, when you understand it this way, there's another thing you need to understand. Look out for, in the word that you've been given, are there any words that are repeating? If yes, then you treat the whole case in bits, okay? And when you finish, you add them up. Now, in this story, we have 3 E's. So it's possible to arrange 4 letters, okay? Starting with a P or containing a P and will not contain an E. Let me give you an example. I can have P, S, H, O, right? 4 letters, right? Doesn't contain an E. So you deal with when it does not contain an E, when it contains 1 E, when it contains 2 E's, when it contains 3 E's. Okay, so it means we've captured all round. So you do the restriction, they said it contains exactly 1p, do that. But be careful, look out for situations where there are some letters repeating in that word. And then you do when it does not contain it, when it contains 1, 2, 3, you get the idea. Okay, so now let's start. So let's start with no E. So no E. So we have the P there, we have 3 more slots, okay? So if we just need 1 P, it means we can cancel out these P's. Okay, so let me write the word here so that we can play with it. Shopkeeper. Okay, so we don't need the E's, the P's, they are out. Now we said no E's, so let's cancel the E's too. We don't need them. We don't want any E. So how many letters are there that we can choose 3 to fill this? So we have S, so 1, 2, 3, 4, okay, 5. So we have 5 letters. So that is 5 combination 3, okay? We are not going to arrange, we are going to select. So you can see 4 letters are selected combination, not permutation, combination, selection, combination. Okay, so 5 combination 3 will give us 10. Great. Then when it contains 1E, so we have 1E. So we still have the P there, yes, and then we have 1E there. Okay, so we are left with 2 slots that we have to choose. But we have 5 at our disposal to choose 2 to fill there. So that's 5 combination 2. And that, ladies and gentlemen, is also 10. Let me check it out. 5 combination 2 is 10. Great. Now let's look at when we have what? 2 E's. So 2 E's will be, we have the P there, an E, another E. Okay, so we are left with 1 last slot, but we have 5 observations there. Okay, so that would be 5 combination 1. We just need 1 of them, and that's 5. Then when we have 3 E's, so that's P, E, E, E. We are done. We have arranged it. So those 5, will we choose some? No. We formed the word. So that's 5 combination 0, and that is 1. Okay, let me check that one. 5 combination 0, just to be sure. 5 combination 0. Yeah, it's 1. So when you finish, you now write 10 plus 10 plus 5 plus 1, and that is 26 ways to do this. Okay, so that's the idea. That's the idea. Feel free to pause the video at this point and then synchronize what I've told you. Then you continue. Okay. So that is for October, November 2020. The next question is 5-3 October, November. Now, at this stage, if you find the video useful, I'd like you to suggest it to your friends. Everyone is preparing to write the A levels. I think they will like it. And if you like it, comment on it, share it with your friends. If you don't, give it a dislike. Okay. A committee of 6 people, that's the next question, to be chosen from 9 women and 5 men. Okay. Find the number of ways in which the 6 people can be chosen if there must be more women than what? Men. That's a restriction. So we have women 9, men 5, and we are going to choose how many people? 6. Great. But the only catch here is that more women than what? Men. So that means that there can be, the committee will be full of women, no man. Okay, so that's 6 women, no man. Or 5 women on the committee, 1 man. Or 4 women on the committee, 2 men, still making 6. You cannot choose 3 men on the committee, 3 women, because that will be even. Okay, they will be equal. And the restriction is saying that more women than men. So I think this is where you end. You cannot have any other possible outcome. Okay, so now let's start to really answer this question. So the first will be 9 combination 6 times 5 combination 0, plus the second root would be 9 combination 5 times what? 5 combination 1, plus then 9 combination 4 times 5 combination 2. All right, now you'll be tempted to put everything in the calculator and write your answer. That is where Cambridge will say that, well, you missed 1 mark. So at this stage, I want you to do it in bits, okay? So start with 9 combination 6 times 5 combination 0, and your answer is 84. Write it down, 84 plus. Then you do 9 combination 5 times 5 combination 1, and your answer is 630 plus. Then you do 9 combination 4 times 5 combination 2, and your answer is 1260. Now you can add everything up. So 84 plus 360 plus 1260, and your answer is 1974, like someone's birth year. Okay, all right. Then question, the B part says the 9 women and the 5 men must include a sister and a brother. Okay, same committee going to select 6. Now you must include a sister and a brother. Find the number of ways that the committee can be chosen if the sister and the brother cannot both be on the committee. Okay, they cannot be there. Now you must understand what is happening. The 2 cannot be there. So that means that 1 person can be there, maybe the sister is there and the brother is not there, or the brother is there, the sister is not there, or both are not there. Okay, the point is that they both cannot be on the committee. So these three possible things must be captured: sister there, brother not there, or brother there, sister not there, or both not there. Okay, so let's do that. Now let's start with sister in. I'll just use in and out. Sister in, brother out. Then later I'll come and do brother in, sister out. Okay, then I'll come and do maybe both out. Both out. Right, then I'll add the answers and then we are good to go. Let's give it a try. Now let's start with the reasoning. You know, if there are 9 women and then 5 men, in order 14 people there, the brother is out. We can't choose him. So that leaves us with 13. And we are saying that the sister is already in. So the sister is part of the committee. So she's not going to be part of the selection. That reduces the sample to what? 12. So we have 12 combination, not 6, because the sister is already there. So we need to select 5 more people to go and add to their sister. So that's 12 combination 5. And 12 combination 5 will give us 7, 9, 2. Now the same thinking is true when the brother is in and the sister is not. So that is also 12 combination 5, giving us 7, 9, 2. Now when both are out, okay, the 14 sample reduced straight to 12. And now we are going to choose 6 people. So that's 12 combination 6. And from the calculator, 12 combination 6 is 9, 2, 4. Excuse me. So now we've captured everything. So we have, let's add them up and then we are good to go. We have 7, 9, 2 plus 7, 9, 2 plus 9, 2, 4. And according to our calculator, we have 2508. And we are good to go. Okay, so that's how to approach the question. All right. So we have another one here. Says that find the number of different possible selection of the letters of 9 letters in the word celestial. All right, so you are going to arrange this 9. So that's 9 factorial. But ask yourself, do we have any repetitions there? Yeah, the e's are repeating. 2 e's are there, so that's 2 factorial, and then 2 l's are there times 2 factorial. All right, and then you are done. So that's 9 factorial over 2 factorial times 2 factorial, and that should give you 90,720. Okay, the B part says that find the number of different arrangements of the 9 letters in the word celestial, in which the first is C, the fifth is T, and then the last is E. Okay, so let's get our 9 dashes. 1, 2, 3, 4, 5, 6, 7, 8, 9. The first is what? A C. Now the fifth, 1, 2, 3, 4, 5. The fifth is a T, and the last is an E. Okay, so these are actually your restriction. They are telling you to put them there. So you put them there, you are done. How many slots are there? 1, 2, 3, 4, 5, 6. 6, and you are going to arrange how many letters more? Let's see. We took the E, one of the E out, one of the T, and then the C. So we are left with 1, 2, 3, 4, 5, 6. Actually, 6 slots. You are going to arrange 6 there. That's, you can just say a 6 factorial. Okay. And do we have any repetitions? Yes, the L's are 2. The 2 L's are repeating. So you divide by 2 factorial. And then that will give you 6 factorial over 2 factorial. And that is 360. Okay. Or, if you don't want this approach, you can also say that since there are 6 slots and you are going to arrange 6 items there, then that's 6 permutation 6. But remember that the L's are repeating. So divided by 2 factorial. And it should give you the same answer actually. Let's see, 6 permutation 6 over 2 factorial, and that's also 360. Great. So The thinking is up to you. All right, then it says that find the probability that a randomly chosen arrangement of the 9 letters in the word celestial does not have the E's together. So you are going to split the E's. Okay, so let's arrange the ones that they didn't talk about first. So we can have C here, L followed by L, followed by S, followed by T, I, A, and then L. Then let's put dashes. Okay, dash beginning. Okay, till a dash ends it. So now how many letters have we actually put there? We have 1, 2, 3, 4, 5, 6, 7. So that means we have 7 factorial ways. But be careful, there are 2 L's that are repeating, so divide by 2 factorial. Times, how many slots do we have? 1, 2, 3, 4, 5, 6, 7, 8. 8 slots. And you are going to arrange how many? 2 E's. Okay, so that's permutation 2. But those 2 E's are actually similar, okay, identical items. So you divide by 2 factorial. Therefore, you have 7 factorial over 2 factorial times 8 permutation 2 divided by 2 factorial. And that gives you 7560. Okay, good to go. Now the next thing that you want to consider, so why did they give us all this space here? Well, that's Cambridge for you for 4 marks. Says 5 letters are selected. Okay, selected combination. Be careful, combination are selected from the 9 letters in the word celestial. Find the number of different selections if the 5 must include at least 1 E and at most 1 L. Wow, this is interesting. At least 1 E, at most 1 L. Now this should tell you that at least means from 1 E above. So there can be 1 E. Actually, there are only 2 E's in the letter, in the word celestial. So there could be 1 E and there could be 2 E's, okay? And then at most 1 L, that means 1 L, at the maximum is 1 L and the minimum is 0. This is English, nothing to do with S1, English. Okay, so 5 letters, okay? Let's start with the restriction itself. It's good to begin from there. So let's go with 1 E, 1 L. So 5 letters. So we have our E and then we have our L. Now that means that we are left with 3 more slots to fill. Okay, now we need only 1 E and 1 L. So if you have the word celestial, and then we don't need any more of the E's or the L's, then it means that we are left with 1, 2, 3, 4, 5. Okay, we have 5 items to use, and then we are going to choose 3 to fill that, and that is 10. 5 combination 3 is 10. Now that you've done that, let's go for when there are no L. You know, this says at most 1 L. So you've done that. Let's go for at most, I told you, is 1 or 0. Okay, so let's go for when there's E, all right, but there's no L. So that means there are 4 slots to fill, and that would be 5 combination 4. And 5 combination 4 is 5. Okay, now the next thing I want us to do is, we are done with the 1E. Okay, 1E arrangement, we are done. Let's go and do 2 E's because there's at least. Okay, so 2 E's. E, E. So we've done 2 E's, and let's do 2 E's with 1 L. So let's include the L. That means we have 2 slots to fill. So we have 5 combination 2, and that is 10. Okay, now let's do 2 E's and no L. Okay, since at most 1 L, so we've done the 1 L, we have to do the 0 L's. So that means we have 3 slots to fill. So that's 5 combination 3, and that is 10. All right, so when you finish, I think this is it. You cannot have 3 E's and then no L or 1 L. You can't have these because there are only 2 E's in the word celestial. Okay, all right, let's add them up and we are good to go. So we have 10 plus 5 plus 10 plus 10, and that is 35. You see the way I've done this? I did not just add it vertically like this. I wrote it horizontally before adding, because this is 3 marks. Cambridge is going to give you 1 mark for the possible selections that you've done. They will give you M1 for you adding it up, and then A1 for the 35 that you have put down. So don't jump any step. Go through everything, score everything, okay? All right. So that's MG53. And let me look at this question, and then I'll call it a day. Okay. It's a lot. I'll leave the worksheet in the description below so that you can go through, and then if you have any question, comment there. Someone would help you. If no one comments on it, I'll be there to give you an idea to go about it. Okay. All right. And those of you who know me personally, you can just send me a message. Okay, so that is about a question about summertime. Well, find a number of different ways in which the 10 letters of the word summertime can be arranged so that the E, there's an E at the beginning, E at the end. Well, let's put them down. E starts, E ends. So that means how many letters are in the middle? You've taken 2 out, so you're left with 8. So that's 8 factorial. But let's go and see if there are some repetitions. Well, there are, because we have some M's that are repeating. How many M's? 3. Apart from the M, is there any other word or letter? Okay, I think there's only the M that's repeating, right? Great. If I make a mistake, comment in the session. So that's 8 factorial divided by 3 factorial, right? So that is it. Let's put that on the calculator. 8 factorial by 3 factorial. And that is 6720. We are done. B. Find the number of different ways in which the 10 letters of the word summertime can be arranged so that E's are not together. So by now, I hope you've seen how Cambridge likes to set the question. When they are together, when they are not together, when one is standing here, one is there. It's the same thing that they keep asking, okay? So let's do that. Now, the E's are not together. So let's talk about the ones that are actually can be together, okay? Let's arrange those ones. After that, we split the E's. That's the idea. So we can have S, U, M, M, R, T, I, M, okay? Now, let's put dashes starting and dash ending. So we have dash, 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 dash. Okay, how many letters have we already put there? 1, 2, 3, 4, 5, 6, 7, 8. So that is 8 factorial ways to arrange this. But the M's are repeating, so that's divided by 3 factorial times how many dashes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, and any of these 9 can contain the E. Okay, so that is 9 permutation 2. Okay, we are going to arrange those two E's, but the E's themselves are identical, so you have to divide by what? 2 factorial. So let's put that on the calculator. We have 8 factorial over 3 factorial times 9 permutation 2 divided by 2 factorial. Great. So you have 241920. Okay. All right. For your 4 marks, I think this is pretty much cool to have 4 marks for this. All right. So the C part says that the 4 letters are what? Selected combination. Find the number of different selections if the 4 letters must include at least 1 M and exactly what? 1 E. E is 1. M at least 1 M. How many M's are there? 3. Now I gave you a plan already in the previous solution. Now the English is that at least 1 M. So that means 1 M or 2 M's or 3 M's. Since there are 3 M's in the word summertime. So you cannot go to 4 M's. That'll be crazy. It doesn't exist. And then it says at exactly one E, exactly one E. So at any point, the word you are going to arrange has to have only one E. You cannot have two E's. I mean, this means you are not reading. Okay, so let's do that. So since it has exactly one E, let's start with when it has one E, one M. Okay, so that is E starts. Okay, and then let's put the M there. There's a 4 letters, so we have 2 more slots to fill. But that's how I like to do it. I'll write summertime, summer time, and then I'll just cancel out the ones I don't need. So I need only one E, so I will not need them. I need only one M, so M out, M out, M out. What are the letters that I can use? I can use 1, 2, 3, 4, 5, 5. Okay, so that's 5 combination 2. Okay, out of the 5, I'm going to choose 2 to fill that. So that's 10. Then I go 1E. How many M's now? 2. So I have M, M. So I've filled 3 out of the 4 letters. I have 1 more to fill. That's 5 combination 1. That's 5. Then I have E, M, 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 when there's 3 M's. I think we have about 4 of them. So that means that the 5 over there, we are not going to choose any. So that's combination 0, and that's 1. And you are done. So you add them up. 10 plus 5 plus 1, giving you 16. Now, some of you wouldn't do the last one. That's the 5 combination 0. You wouldn't do it. But you must do it. Okay? Because that's also a selection. You can have 1 E and 3 M's. So you will actually write 15 and you'll be wrong for that. So you have to do the last one, okay? So that your answer is 16. All right, so this is where I'll end. And I'll leave the rest in the description, okay? I'll actually put down the worksheet together with the solution that I have done here in the description. Go through the rest, and I think you'll be fine. If you have a problem, just be very specific when you are referencing it. So give the year, the question